Hi, I'm Paul Kilgan from GK Tuition, and in this video I want to talk to you about patterns. Now, the question I've chosen to go through here is 2019 Paper 1 Question 7. In this question we're introduced to the Cantor set, where we start off with a line that goes from 0 to 1. And in the first step, the middle 1/3 is removed from the Cantor, or is removed from the line, and we're left with the Cantor set. In the next step, the middle 1/3 of the two remaining lines is removed. And in the next step, the middle 1/3 of the four remaining lines are removed. And the first part of this question asks me to work out what proportion of the original line is removed with each step. Now, the key to doing this one is to realize that in step 1, so this is my step 1, the line was divided into thirds, and one of them was removed. So 1/3 is gone. In the next step, it was divided into ninths. It was divided into ninths in total, and two more bits were removed. So 2/9 were removed. So the first step, it's divided into thirds. The second step is divided into ninths. The third step, it's obviously divided into 27ths. So it's divided in, so I know that the bottom is going up as a multiple of 3. So this was in thirds, in ninths, in 27ths. In the fourth step will be divided into 81 different sections, and the last step they're divided into 240 thirds. Now, it's relatively straightforward then, once you've identified that, to work out what proportion is removed in the third step. Look at the first step, one bit was removed, so it was 1/3. In the next step, there was this section, and this section was also removed, so there was 2/9 removed. And in the last one, the last diagram we've been given, they've removed 4 more sections. There's 4 more bits that they've taken out, so they've removed 4 27ths in step 3. Now, you should realize, you can notice a pattern now. On the top line I had 1, then 2, then 4. Clearly it's doubling every time. The next section I'm going to be removing 8 over 81, and the next one is going to be 16 over 243. So that's your final answer for A part 1. Okay, so in A part 1, we worked out that in the first step, 1/3 is removed, then 2/9, then 4 over 27, then 8 over 81, and 16 over 243. In A part 2, it asks me to work out what proportion is removed, or what fraction is removed after n steps. So you need to realize that this is actually a geometric series, that there's a common ratio involved here. So once you realize it's a geometric series, they're asking you to work out how much is removed after n steps. So that just means if I added them all up, or in other words, that means use the formula for Sn. The formula Sn for a geometric series is a times 1 minus or to the power of n over 1 minus or, where a represents the first term, which in this case is clearly 1/3, and or represents the common ratio, which in this case is 2/3. Now, if you weren't 100% sure whether it was a geometric series or not, you should actually try and work out your common ratio twice. So I've done it once there. The second term divided by the first term gives me 2/3. But if this is a geometric series, any term divided by the previous term should always give you the same answer. So we could just verify it by checking the fourth one and the third one. The fourth one is 8 over 81 divided by 4 over 27. If the fourth one divided by the third one gives me the same answer, then I know it's a geometric series. And in this case, if you plug that into your calculator, once again you're going to get 2/3. So happy days. I know that what I do in each case is I just multiply by 2/3, and that gives me the next one. And once I've identified that, I can just sum into my formula Sn. So in this case, it will just become 1/3 times 1 minus 2/3 to the power of n, and that's all divided by 1 minus 2/3. So all I've done there is, instead of a, I subbed in 1/3, instead of or, I subbed in 2/3. But you have to be very, very careful here. The 2/3 to the power of n, or any number to the power of an unknown, is bad news. And in general, you shouldn't, I can't multiply out the top line now. 1/3, I can't multiply the 1/3 by the 2/3. So in general, I'd advise you to avoid that if you can. However, we can simplify this quite a lot. Let's leave the top line as it is, but the bottom line I can clearly simplify. 1 minus 2/3 just gives me 1/3. And now here I could divide the 1/3 on the bottom into the 1/3 on the top, and they essentially just cancel each other out, or they divide in, 1/3 divides into 1/3 once. So your final answer simplified fully, I can write my Sn is 1 minus 2/3 to the power of n. And that's your Sn simplified fully. So let's say if I wanted to work out how much was removed after 50 steps, just sub in 50, and whatever I get there, that's my answer. So your final answer for A part 2, it just gives you this. Okay, in A part 3, we're still talking about the total that has been removed. Except this time we're asked to work out how much is removed after an infinite amount of steps. So in this case, clearly we're looking at the formula for S infinity, which is A over 1 minus OR, where A represents the first term and OR represents the common ratio. If I just sub in here, my final answer just works out as 1. So this sequence went on forever. More or less, basically the entire line would eventually be removed. More or less, the entire line would eventually be removed. So my final answer there is 1. Okay, in B part 1, we're asked to identify the endpoints labelled as A, B, C, D, E, and F in the original diagram. Now, I'm going to do this one line at a time. So the one I've written here is step A. In step A, remember we discussed it's been divided into thirds. So this is 1/3, 2/3, and 3/3. So clearly from here to here is 1/3, from here to here is 2/3, from here to here is 3/3. So the first one, you can say that A is 2/3. Let's now look at the next line. Okay, in step 2, remember we discussed in step 2 the line is divided into ninths. So they've labelled 0, 1/9, they've labelled 1/3, they've labelled 2/3, and they've labelled 1. But in my mind it makes a lot more sense if we think of this, rather than thinking of it as 1/3, we think of it as 3/9. And rather than think of it as 2/3, we think of it as 6/9. And instead of 1, we think of it as 9 over 9. That makes it very easy to identify B, C, and D. So this is, my first dot is 0, then 1/9. Clearly B is going to be at 2/9. Then I get 3/9. There's a middle bit in this that I've done nothing in between. So from 3/9 to 6/9 is blank. And then the next one I get to 7 over 9. And the next one I get to 8 over 9. So in other words, B works out as 2/9, C is 7/9, and D is 8/9. Now in the next line we're dividing it into 27ths so we can work out E and F. Okay, so remember in the final line everything's been divided into 27ths. They've labelled 1/9, but in my mind that's 3 over 27. They've labelled 1/3, which is the same as 9 over 27. They've labelled 2/3, which is the same as 18 over 27. And they've labelled my 1, which is the 27 over 27. So we can work this out. So I think the easiest way, if you look at 1/9 and go backwards to get to E, I know that, sorry, not 1/9, 1/3. Where I have 1/3, that's the same as 9 over 27. If we go back to 1 dot, that's 8 27ths, and we go back another dot, that's 7 27ths. So based on that logic, I can work out that E is actually 7 27ths along the line. I do the same thing, work backwards from 1. I know that 1 is 27 over 27, the previous one is 26 27ths, and then the one before that, which is F, will work out as 25 over 27. So now we know that F must be the 25 over 27. That's how far it is along the line. So let's look now and let's move on to B part 2. Now for B part 2, it says give a reason why 1/3 minus 1/9 plus 1 over 27 minus 1 over 81 is a point in the Cantor set. Now, all they're actually looking for here is, all you actually had to mention was that it is the endpoint of a segment. And I think it's very important you add them all together and you get a value. So if you add them together, that means you're 20 over 81 of the way across your line. But if you even look at your diagram, if you go up 1/3 and then you went back 1/9, that gets you to the point B. Then you go up 1 over 27, that gets you to the point E. If you then went back 1 over 81, it's not in the diagram, but you can visualize that actually that would also be a point. So you can see it from the diagram, but all they're looking for in the marking scheme there is that you mention that it's a point, it is the end point of a segment, or that you work out your 20 over 81. Okay, the final part, now B part 3 of this question, it says the limit of this series, and it's the same series from B part 2, it is a point. If that sequence went on forever, it is a point on the Cantor set. And it asks you to find that point. Now, you need to recognize that this is actually a geometric series, Because if I get 1/3 and I multiply by minus 1/3, I get to here. If I multiply by minus 1/3, I'd get to there. If I multiply by minus 1/3 again, I'd get to minus 1 over 81. Then I'd get to plus 1 over 243, and so on and so forth. And that would just keep going on. Now remember, if you don't recognize it's a geometric series, you should try a couple of them. So minus 1/9 divided by 1/3 will give you minus 1/3. As will the third one divided by the second one is also minus 1/3. The next one, and if we kept going on in this series, that would keep happening. So there's a common ratio, means it's a geometric series. And if we're looking for the limit of this series, that means we're looking for S infinity. This went on forever. What point is it approaching? So I just sub in A is 1/3, or is minus 1/3. It's a relatively straightforward formula, and my S infinity works out as 1/4. And that's your final answer for this part of the question. Now I hope that makes sense. If there's anything you're unsure of there, or you'd like me to explain it differently, then just let me know in class or send me an email and I'll try and clarify it for you.